Hi, I'm Dr. De Bruin, and this is another quick walkthrough of how to answer an exam question from the atomic structure topic of AQA A-level Chemistry. In the previous video in this series, we also looked at time of flight mass spec, but in this question, we're not working out the distance again, we're actually looking at the time taken, and we're going to consider two different isotopes. So the key to unlocking this question is understanding that in the mass spec, all ions are going to be accelerated until they have the same amount of kinetic energy. In other words, EK is equal to EK. Now actually in A-level chemistry, we're going to be nice to you. Unlike GCSE physics, we are going to give you the equation for kinetic energy, but it's worth having it memorised, particularly if you're not very comfortable with rearranging things under pressure. But what we can say now is that half mv squared for carbon 12 will be equal to half mv squared for carbon 13. So those are the kinetic energy equations for each of the isotopes. The next thing I'm going to do is to get rid of anything I can get rid of. So by multiplying both sides of the equation by 2, I can turn this into just mv squared is mv squared. Now, strictly speaking, I could work out the exact mass of each isotope in kilograms like I did in some of the previous questions, but actually what I'm interested in here is the ratio between those masses. So I'm just going to use 12 and 13, and that's fine because mv squared doesn't actually equal something. It's not like when we're working out moles and we need to make sure we convert between centimetres cubed and decimeters cubed because that number is meaningful. This mv squared that I'm going to work out here doesn't actually mean anything, so it doesn't matter if I don't use the true mass. So what we're saying is that 12 multiplied by V1, which is the velocity of the carbon 12 isotope squared, is equal to 13 multiplied by the velocity of the carbon 13 isotope squared, which here I'm representing with V2. Hopefully you can understand what I mean with the V1 and the V2. So now I'm going to pull both of those numbers onto the same side of the equation to give me a conversion factor. So 12 over 13 multiplied by the velocity of the carbon 12 isotope squared is going to be equal to the velocity of the carbon 13 isotope squared. You can see now why I'm using V1 and V2 and not trying to write this all out in words every time. So what I now need is the velocity of that carbon 12 isotope. So I know that velocity is distance divided by time, and given both of those numbers in the question, so I can just substitute those in, and that gives me a velocity of 3,160 meters per second. I'm not doing any rounding at this point. I'm using the full calculator display or using the answer button. I never want to round until the end of the question. So I can now square that and get an answer for v squared, because of course that's what I've been using in my previous equation. And then I can use that together with my conversion factor to give a value for v squared for the carbon 13 isotope. So you can see here it's a little bit lower because it's a heavier isotope, so as the mass increases the velocity must decrease in order for the amount of kinetic energy to remain constant. So I just want velocity on its own, so I'm going to need to square root that next, which gives me an answer of 3035.887 meters per second. So that makes sense. It's a heavier isotope, it's moving slightly slower. And this is the point where people get tripped up because they get so excited to have worked out velocity that they forget the question didn't ask them about velocity, it asked them about time. So we now need another rearranged version of our velocity is distance over time equation. So time is distance divided by velocity. So we go back to that distance of the flight tube, the 0.850, and we divide it by our new velocity. And we're going to get a time of 0.000279981 seconds. Now, before I finish off, I need to think about significant figures. So in the question, I've got a couple of different numbers and they are to 3 significant figures. Therefore, my answer should be to 3 significant figures. And I've put it back into standard form just because it makes it a little bit nicer to look at and because that's how they gave it to me in the question. But unless the question explicitly says to you, give your answer in standard form, then it would be fine if you left it in long form as well. Thank you very much for watching, and I hope that you are finding these A-level chemistry exam question walkthrough videos useful. If you are, then don't forget to like and subscribe and let me know in the comments which topics you'd like me to tackle next.